All right. Hello, everybody, and welcome to a screening of Behind the Code with Anders Hejlsberg. Behind the Code is a documentary interview series produced by the Technical Community Network, and our focus is to create networking and development opportunities for our senior technical contributors here at Microsoft. And how Behind the Code fits in all this is our senior employees here at Microsoft have some great stories, have some great history of technology kind of involved with their careers. And so we take the time to sit down and talk with them a little bit about their career, the history of technology, and things like that. So within this next about 45 minutes or so, you'll get to learn a little bit more about the story of Anders Hejlsberg and things related to his career. And then we'll stop the tape at the Q&A session that actually is recorded here and give you guys, the audience member, an opportunity to ask questions of Anders. So without further ado, I will press play, and I hope you enjoy Behind the Code. Hello. We actually host all these on MSDN's channel 9, so if you want to take a look at some other ones, you can access them there. But with that, I'd like to bring up Anders Hejlsberg here to answer your questions.
Right,
Thank you, Anders.
Thank you. Well, I don't think there's any set agenda or anything. I'll just, take questions on whatever we saw here or whatever else comes to mind. If you have any. Yeah,
at the end of the film there, you said that you thought the future programming languages was getting more declarative.
Mm-hmm.
But of course, there have been declarative languages around for
Right.
at least 40 years.
Right.
And they established little niche sort of cult communities, and people are really enthusiastic about them, but they never have acquired widespread acceptance. What do you think it's going to take to get over that?
That's a great question, and I think I should actually probably modify the answer a little bit and say I think advances are going to happen in the declarative space, but really it's the happy marriage of mainstream programming languages with declarative methodologies. I think that really is where we're going to see sort of advancements, at least in the near future. I mean, there's so much interesting stuff happening in declarative languages or rules-based languages or functional programming, which has been huge in the last 10 years. And it's, when you look at the stuff we're doing with Link now and C# 3.0, it's really like we're turning C# into a functional programming language. But it's still an imperative programming language too, so when the functional paradigm doesn't work for you, we're not religious about it, and you get to go write those 2 lines of code that tie to this API that's out there, and sure, it modifies state, and so what, because it works, right? So I think it all has to be coupled with a healthy dose of pragmatism and plenty of escape valves, and quite often domain-specific languages tend to be great at their particular domain and suck at everything else, right? And we're sort of trying to have our cake and eat it too. Tom?
Have you coded in F#?
Only little bitty stuff, I mean, I'm not, I grew up an imperative programmer, and effectively this, in many ways, has been me learning functional programming, or at least the principles behind it. So yeah, in my day-to-day coding, no, I got to tell you, it's more C# and whatever. But I have the utmost respect for Don's work and whatever. I think all the work he's done on generics has just been wonderful and has been a deep enabler for the stuff we're doing now, which really is a second-tier effect of having a stronger type system, or more expressive type system, I should say. Yeah.
Is there any particular language that you use just for fun in your spare time, just to kind of see what other people are doing with languages right now?
Let's see, what have I toyed around with recently? Well, I've looked at a lot at some of the dynamic languages that are out there. More, not so much writing code, but just sort of like trying to understand, what are the things that make them tick. Stuff like Ruby and Python and whatever. And I think like the functional programming languages have been interesting. I tend to, when I code, I actually tend to try to pick pragmatic projects that end up in the product somehow. So I've done most of the X-Link thing that we're doing in the Link project now is code that I've written. And so that's been fun, sort of, to design an object model and put queries into it and whatever. So most of my programming I end up doing on .NET, probably. Yeah.
Do you have a comment where you see contracts being post conditions?
I think there's been some really interesting work done with SpecSharp and some of the research projects, pre and post conditions and variants and non-nullable types and whatever. My biggest concern so far has been how do we retrofit it onto the existing platform, because for better or for worse, we built a platform without these concepts. And now we're sort of faced with having to fit it in somehow. And so, for example, pre and post conditions are very much sort of like a formalization of the if statements that we all write at the beginning of each method that test the validness of parameters. And I know that there's work now where we're trying to take the BCL and retrofit it with pre and post conditions. And I think that's great stuff, and if that ends up actually panning out, where we can truly take these mechanisms and use them, not just as annotations that are helpful, but really as part of the production code, then I think we're starting to advance the state of the art. So it's something we're keeping an eye on for sure. Yep.
So if you and Philippe had a disagreement, with one.
Well, I'd probably Philippe. Philippe is an interesting character. I used to say, whenever you had a meeting with Philippe, you better think very carefully about your first sentence, because that was about the only one you were going to get in. And then thereafter, the thing would just derail to whatever Philippe was thinking about right now, and then that it was all over the map all the time. He was hugely inspirational, a great company builder, but terrible at actually running an existing organization, and it was hard for him to stick with something. Do you know what I mean? He's massive attention deficit disorder, if you will, but brilliantly intelligent at the same time. So yeah, fun guy to work with for sure.
We all know that not all data is relational.
Right.
On the other hand, now clarity and everything around it is so much focused on the relational space that we forget that there's lots of other stuff out there.
Right.
Like perhaps, let's say, Excel spreadsheet formulas, multidimensional data, OLAP cubes, and
right.
lots of other things. What do you plan about that?
Okay. Well, it's funny because I think, if you look at the stuff we're doing with Link, I think one of the hallmarks of it is the fact that the query language that we have created is a hierarchical query language as much as it is a relational query language. It's just that relational data is so occupies such a large portion of people's frontal lobes that they tend, and because it starts with a from and a select and a where, they immediately think that it's got to be like SQL, and it really isn't at all. If you look at that, what Link does, it has the same expressiveness as SQL, but certainly also the same expressiveness as XQuery, which is totally like a relational program, a hierarchical query language. You're right that when you get into sort of data cubes and multi-dimensional data sets or whatever, we're not directly doing anything in our query comprehensions for that domain, but certainly the functional programming ideas that really underlie the stuff we're doing, the ability to write lambda expressions that are strongly typed and type inference around them, and generating expression trees so you can have sort of remote or runtime-based execution and reasoning over the entire query. All of that stuff is equally applicable, I think, to scientific computing and other problem domains. It just so happens that it maybe doesn't come along with a nice comprehension syntax, but if you look at how we did the comprehensions, you also see that they're very, very just a thin syntactic veneer, really, and And we could put other veneers in there if they turn out to be useful enough, or we could even think about like a discipline around defining the veneers, which we have not done so far.
For instance, not everything is a sequence. Most of language built-in primitives, constructs for comprehensions,
Yeah.
are built around.
Right.
And not everything is a sequence.
Right.
Okay. Thanks.
Right. No, that's a good point. Yeah.
General question on the solution evaluation, how you come to a conclusion that this is the solution we're going to go with. Is it most of it went in top-down approach? Okay, here's what I think should be, and then you start evaluating that solution, or do you go from, let me think of the solution and then right through it to the...
Yeah. Well, so the most recent example is the stuff we've done with language integrated query, and it's funny. You sort of. It's kind of like you start out by walking into a dark room, right? You kind of know you want to be in this room that has to do with integration of query, but you've never been there before, and the lights are not on. And you sort of grovel around, you know what I mean? And then you sort of come to realize some of the things that are true, and then you build a particular solution, and then like in the beginning with LINQ, we sort of burned in some relational operators into the language, like a where and a select and a projection, filtering, grouping, and whatever. And then eventually you sort of come to the realization that what you built is actually an instance of a class of problem. And that's sort of the aha moment that I think where you kind of go, oh, I see. And you sort of felt all along that you were kind of prostituting the language, because why is it that there are these 10 keywords and not 11 or not 9, and why is it that they only work on sequences, or why, and then like you sort of come to gradually realize that there's a class of problem you could solve by having a more abstracted set of language extensions, and ideally you also recognize what some of the other uses for those language extensions are. And if you look at how C# 3.0 is built, it's interesting how we have total separation, in a sense, between church and state here, that we have 6 or 7 language extensions that are here. So lambda expressions and anonymous types and extension methods and blah, blah, blah. And then we have the application of that, which is, hey, deep integration of data. Do you know what I mean? But really the language knows nothing of the actual APIs that we apply it to. It's entirely based on following a pattern. And if we get it wrong with Xlink or D-Link or the APIs we're building now, well, we could throw them out, and the language would not go down the tubes with it, because we could just go build new ones as long as the pattern we've captured is right. So I think it's always important, at least from a language design perspective, to try to capture the class of solution as opposed to the instance. I know that this is sort of vague, and but it's all vague, right? I mean, but
Overall, OOP.
yeah. Well, I'm just using OOP analogies here, right? But I mean, ideally, a language extension should have multiple uses, and so you center it around a particular solution, but you build it in a way where it's general purpose. And like take extension methods, for example. It is the mechanism whereby we introduce a query language over IEnumerable of T, But it's greatly useful for a bunch of other things. And lambda expressions are greatly useful for all sorts of things like rule systems and what have you, like all sorts of functional programming stuff, right? And it just turns out the queries are sort of one of that family. But if you can capture the class in the language and the instance as the product you ship, then you're much better off. Because languages tend to live longer than APIs, right? And so you really want to decouple yourself from too tight of a binding. Yeah.
Do you think the pervasiveness of the phone and the problem people are trying to solve with mobile devices, will they affect languages, or is that more higher level?
Well, that's a good question. I think, when I look at where we're trying to go, not so much now with languages, but more what we use the languages, and sort of get into the declarative stuff again, I think that declarative approaches on all of these proliferations of devices and different UI form factors and whatever if we can get to writing our application in a more declarative and adaptive style, where you sort of declare like the intent of the UI more than exactly here how the pixels are laid out and so forth. But I think I'm just saying sort of obvious things here. But yeah, I'm not sure I can apply exactly anything other than that on devices. Yeah, I mean I think it's interesting to think about where we will go with the CLR, for example, and our programming platform. Right now, the compact framework is we're sort of we're sort of in a funny position about where we want to be with the compact framework and other platforms and whatever. And I think at some point we're going to have to make some decisions about to what extent we want to play on other OSs and other environments, because we tend to be very desktop centric in our thinking, and really .NET in many ways was designed to go to these other platforms, and the notion that we have an abstraction over the execution environment and IL and whatever makes it eminently adaptable. It's just that we've been very sort of unclear about the business decisions of going there. Yeah.
I have a technical question.
Mm-hmm.
Delegates.
Mm-hmm.
Some days ago we had a discussion about delegates. So why are they so complex? Meaning that they have variables in there instead of just taking values.
They have variables in there.
Closures. I mean, if you take the closure, they have variables. I mean, you have local variables.
You're talking about when you do anonymous methods in C# or lambdas. And okay, so let me say a few things about, I mean, for those of you who don't know delegates are effectively what I think of them as object-oriented function pointers, or the ability to capture a strongly typed reference to a method with a certain signature, certain declared signature on any old object, or a static method where there's no receiver. And then you can make calls, and you can effectively have a delegate reference a method as long as the signatures of what the delegate expects and the method are compatible. Delegates are I find, well, if you think now about functional programming, then effectively delegates are sort of the type of a lambda expression is a delegate type, right? So when you capture a function taking 2-int returning string, that is a delegate type, and what you can store in that delegate type is a reference to a method that you wrote, or you can write a method inline as a lambda expression, and then the compiler generates the method for you and creates a delegate to that method, and that is effectively the result of writing that lambda expression. Now, if in your lambda expression you create a closure on a local variable, is this what you're talking about? Well, that to me is like closures are sort of one of the key operatives in functional programming. Without the ability to close on the lexical environment or capture local variables in a lambda expression, it becomes very hard to do anything meaningful with functional programming. But I'm not sure what exactly was. Is this answering what the question was, or am I heading down the wrong way?
That you could have done it simpler, so that there's always the question that you said that do the things as simple as they could.
Yes, but how could in what way simpler? I'm curious.
I think the question is when you then refer to a local variable in the enclosing scope.
Yes.
There seems to be two choices. One can either copy the value of that.
Why do we reference the L value as opposed to the R value? Is that okay? Well, this gets to effectively, and this, of course, we had lots of discussions about. And I mean, it gets to the root of C# at heart is an imperative programming language, and people have an expectation that a variable is something you can put values into or take values out of, and if you put values into them and then someone else put values into them, well, they're putting them into the same place. And so I think it would run completely counter to programmers' intuitions if we were to capture R values as opposed to L values in delegates. But you're right that if we were to capture only R values, then sometimes we wouldn't have to hoist the local variable into a helper object, or effectively what we're doing is we're taking those local variables we refer to and we're, in a sense, moving them from the stack frame into an object instead, right? So you can have one location that everybody's poking at. I still think that's the right way to view the problem. I understand that if you're coming from a functional programming background where there's only single assignment variables, well, this is a completely bogus argument, right? Because you don't mutate your variables. But the reality is that people do that and have some very strong preconceived notions about how that's supposed to work. And I think we would just be sort of swimming upstream if we tried to do it the other way. There are also other reasons why it turns out to work well to capture the L value. But yeah, anyway, I'll leave it at that. Yeah.
The key component you mentioned in the interview was simplicity. Not taking the literal sense, but have you ever had experience explaining what you have created with the C# to a 7-year-old?
To a 7-year-old, or no? My son is 5.5, and I haven't quite gotten to a point where I'm trying to explain programming to him yet. I probably will one day, and I'm probably in for a nasty surprise. Yeah, and simplicity it's a. Obviously C# is when I say simplicity, I have my own sort of funny thing that I mean with simplicity, because clearly, in terms of, if you look at the definition of the programming languages, there are simpler languages out there like Lisp or whatever you can define in one page, right? But when I talk about simplicity, I'm really sort of talking about something that appeals to people's intuition or whatever, that feels simple, even though it's not necessarily simple in concept. It's simple in use, if you know what I'm saying. And again, it's hard to put an exact definition on that. But yeah, no, I am actually I'm curious about what it'll be like to try and teach my son or my daughter programming, and see how miserably I fail at it.
If you don't mind, I have 2 questions. Well,
Sure.
Actually, I have lots of questions.
Okay.
But I would like to ask only 2.
Okay.
And let me start with a short question. What was the thinking and the main reason behind the immutable strings in CLI?
Right. Okay.
And,
Okay. You want me to do that first, or I think it's the thing that's interesting about immutability is that when you have an immutable type, you can implement value semantics using reference semantics, right? So when strings are immutable, the act of passing a string as an argument or assigning it to a variable is almost free, because you just take the reference, which is most likely already in a CPU register, and you store it there and you're done. Whereas if you're in a by-value model or in a mutable model, then either you burden programmers with manual buffer management as C or C++ do, or well, actually, no, Pascal had a value model for strings, so either you make people do the buffer management, or you implement a value model where you literally copy the characters whenever you pass it as an argument, and that's very expensive. So, for the runtime, having immutable strings turns out to be, a godsend, because you can have this simple mental model of I can just add strings and I can just pass them as arguments, and it's super cheap to do the operations that I most commonly do. It is true that then for certain scenarios, like I am building up a string piecemeal, you got to be careful and not say plus, 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 because you build up every temporary string as well, right? And then you've got to get into string buffers or blah, blah, blah. And then, so there are some things you have to know. But I think the pro and con, I definitely think immutable strings are
So they're definitely very good for implementing the switch statement which deals with the strings, right? So you just compare pointer and that's all.
Well, that's the other thing. You can intern strings, and then you can compare references as well to do string compares. Yeah.
Okay. So the other question is a little bit longer. So I would say that the ultimate definition of the system programming language or environment is self-sufficiency. I mean, C runtime is written in C, modular runtime
right.
is written in modular.
Right.
And for example, in Turbo Pascal, I can recall only few places where you had to use the assembly because it was difficult or even impossible to express in the language.
Mm-hmm.
So when we're talking about that breakdown in the implementation, when the language uses itself for supporting system versus when you use the lower level, like assembly,
right.
it's just kind of seamlessly.
Mm-hmm.
In the CLR versus base class library,
mm-hmm.
that separation looks much more by design because a lot of things which are done in CLR just cannot be done in CLR-based languages, which is by design.
Right.
So the question is, what your personal thoughts about the various attempts of coming up with the pure managed only rating system? So how do you feel about these attempts?
Yeah. It's interesting. I'm not sure that I mean, the thing that's always puzzled me about the quest for the pure managed operating system is the why. Is it just because it could be done, or is there, I would much rather talk about what is the advantage of doing it, or what are the pros and cons, right? I mean, the reality is that the closer you get to the hardware, the more real the concepts that you deal with, in your program become, right? There's only one screen. It is at this address. There's only one I/O port. You can't just have an abstract I/O port and that's garbage collected or whatever, right? I mean, and side effects or GC effects are observable, and so forth. And so, and the hardware, for better or for worse, I mean, it's memory is memory. It's not garbage collected objects, right? And so at some point, the further down you go, the less useful a managed coding environment becomes, and all the way at the bottom, it almost becomes an absurdity, right? Because there's just a disconnect between the abstractions and the reality of what you're programming. And so I think it's fairly meaningful to talk about microkernels and whatever being written in unmanaged code. The question now we can debate sort of then where does the line go, and to what extent are the two worlds aware of each other, right? And I think there are much better things we could do today to accommodate garbage collected applications in the OS than what we actually do, right? And there are much better ways that we could pass information between the two worlds. Often today we're forced to do all of this marshalling by value, to get in and out of the GC arena, because otherwise we can't track what's happening to stuff, and we have to erect markers on the stack because otherwise we can't track the stack frames and so forth. So the cost of transitioning is too high, right?
So as I take it, you personally wouldn't advise people try to use C# to implement garbage collector?
Well, I think there are. I mean, it almost doesn't make sense to talk about, because all of the abstractions that are in C#, half of the language already presupposes the garbage collector, right? So, so it's hard to even do that. I mean, C# is at that next level up and does make an explicit assumption about a managed execution environment and garbage collection, and in return for that we get a freedom of expression that was never available in languages like C or C++ or Turbo Pascal or Delphi. I mean, the notion that, I think it's pretty profound, that what happens when you move from a an unmanaged to a managed environment, the way you think about API design really totally changes. If you look at the Win32 APIs, for example, it's all about call this method passing in a null pointer and a count, and then it'll return how big the buffer is, and then you'll go allocate the buffer, and then it'll fill in the buffer, and you'll pass that as a D word, and it's like there's no type safety. There's like memory management is very confused. Who's supposed to allocate this and get rid of it again? And what if it is almost impossible to return structured data, because now the memory management just like becomes a bloody nightmare, right? Because it's all about flat buffers that get filled in and so forth, where when you get into a G-seed environment, you don't have to think about these things. It is perfectly reasonable for something to return a graph of objects, and we don't have to first like have a gazillion assumptions about, well, the outer object I free, but the inner guy is you free, or whatever, right? And so.
That's not the question.
Okay, sorry, but I'm just going off here. Yeah. Okay. Yeah.
On direction of type systems in Microsoft products, like VB9 was kind of loose type. Now, sorry, the VB used to be loose type. Now VB9 is transforming into a dynamically strong type language, more or less, while C# stays a strong type language. So there's a huge difference between where the two languages are. So,
yeah.
Also in the SQL world, there's basically no type system, or a very primitive one, and you're trying now to integrate with that, and it's probably not easy because SQL is so naive.
Yeah.
Right.
Yeah. I think it's interesting with loose versus strong typing. I actually think that the ideal world is somewhere in between. It's neither black nor white, and I think that there are some interesting advances in programming languages that we can take advantage of, like pattern matching and type inference that we see now in functional programming languages and sort of hybrid languages like Scala, and where the compiler it looks like you're writing script or loosely typed, var x equals blah, and then you do something with x, but lo and behold, var in this language doesn't mean any old object. It means whatever was the type you assigned to it, and then that type further flows, and then flows and flows and flows. Do you know what I mean? And we infer and infer and infer further and further, because at the end of the day, there's a price to be paid for programming in a loosely typed language. Like things that people today expect, like IntelliSense and statement completion and code refactoring, just pretty much are shot in the head if you don't have an expressive type system where you can track what's going on. Like in particular, like refactoring, which I think is like sort of the next big thing up, in terms of how you quickly develop applications and whatever, is if you can't capture what the types are, it is very, very hard to do meaningful refactoring sometimes. And IntelliSense, again, if you have to kiss statement completion goodbye, that's a big problem, right? Because it's such a productivity enabler. So I'm like constantly trying to find ways where we can capture types without them being in your face, right?
What was the reason why type inference hasn't caught on in the past?
Well, I think it's so type inference presupposes that you have a type system that is expressive enough that types can flow. And if you look in other words, you need a generic type system or a parameterized type system, right? And if you look at how type inference works now in C# 3.0, where you write a generic method with, say, take the join method in lint, right? It's this hairy generic method that has 4 type arguments, right? And 4 lambdas that go in, and types flow, from this stream and from that stream, and the extractor of key is the same type as that guy, and then they go in, and then you have a result shaping lambda on the output, but the types flow through that. Do you know what I'm saying? And we understand what comes out on the other end and what goes in, and we can type check that. And having that knowledge there is a deep enabler for a lot of programmer productivity. And I think the there's sort of all this excitement in you know, out there in the industry about Ruby and Ruby on Rails and whatever. And I think you're just, you know, you're taking one set of problems and you're throwing the baby out with the bathwater, right? And yeah, you get simplicity, but lo and behold, your IDE sucks, right? I mean, it can't do anything for you because it doesn't know what you're doing.
So is VB9 the right?
VB9 is an interesting hybrid. I still think that I think there are interesting cases where loose typing is right. With XML, there's something to be said for the fact that you don't have to be schema policed before you can do anything with your XML, right? And XSD is a bloody nightmare, and then I don't want to go there, right? And then so, on the other hand, I do think in VB9 it's a little too easy to accidentally fall into the loosely typed world, right? And then you know, it's always dot, and then you can just say dot on an object, and now you can say anything you care to, right? And then so it's very easy to make a mistake, and I would rather not go there, right? So we're still trying to like do the right thing, you know.
And the last question. In the concurrency space, we are still at the beginning. We don't have there's no type system. We don't have a similar concept that helps us compile type checking for concurrent programs.
Correct. I think we still have lots of ground to cover in concurrency, and it certainly is like every day becoming a more and more acute problem, you know, with sort of Moore's law running out of steam, and then now we're not going to get faster processors, we're going to get more processors, and we better figure out something to do with them, because and you know, I think there's, over the next 5 or 10 years, that the big advance we need to make is to come up with a programming model for concurrent applications that allows every programmer to succeed in writing those types of apps, and we do not have that programming model today.
I'm sorry, we do have to wrap this thing up. So thanks a lot for coming, and thank you very much, Anders, for taking the time.
Thank you.